using physics!
Who are you? It was locked. How'd you get in?
None of that matters. We're just here to show you how to hit the shot.
Using physics.
What do you mean none of that matters?
Watch. I told you. All you had to use was a little bit of physics.
Wait, I don't get how you just did that.
I'll show you. It's pretty simple, actually. Can I erase this?
No.
Okay.
What?
So
What are you doing?
basically, this is a drawing of our motion. The displacements were measured as well as the time, and we chose forward as positive because all of our horizontal motion acts in the forward direction. What we have here is a simple projectile motion. Now, basically, in the horizontal direction, our acceleration is equal to 0 because there's nothing pushing it forward. So that means that if we graph horizontal distance over time, it should be just linear and constant. So that means that since it's linear and constant, the slope of this will be our velocity in the x direction. Now, to calculate it, we can say that at this point here, at the end of our projectile motion, the total displacement is 3.725 meters, and the total time is 0.65 seconds.
So if we want to find the velocity in the x direction, we know that we can find the slope of this graph, which is y2 minus y1 over x2 minus x1, which can also be found by doing delta d, which is our distance, over delta time. And if we plug that in, 3.725 over 0.65, we plug this into our calculator, and we get roughly 5.73 meters per second.
So now that we have our horizontal velocity, we can go about finding our vertical velocity, which is going to be different because of acceleration due to gravity.
Okay, so here are our given values to calculate the velocity in the y direction. We have our acceleration, which is positive 9.8 meters per second squared due to gravity, and we chose positive to be our downwards direction. This is our displacement in the y direction, which is positive 0.435 meters, which we just measured. And this is our time, which is 0.65 seconds. And we know that our time is 0.65 seconds because this is the exact time that was in our x direction as well. And those two are identical. So we use a kinematics equation to calculate the velocity in the y direction. So if you use a calculator to plug in all these values.
Here, I have one.
No, it's okay, I already have one.
You should.
Yeah.
Okay.
And our given value for our velocity is 2.52 meters per second, which is upwards.
Now if we draw our projectile motion, you can see that using our horizontal and vertical velocity, that we can in fact make a triangle. Now, this angle right here is the angle of trajectory at which the ball was thrown, while our hypotenuse is the speed at which the ball was thrown. So if we use trigonometry, we can see that tan theta is equal to opposite over adjacent, which is our vertical velocity divided by our horizontal velocity. And if we do the inverse of tan of that, we can get that our angle is 23.7 degrees. Now, using Pythagorean's theorem, we can calculate our hypotenuse, the speed at which it was thrown, is just the square root of our vertical velocity squared plus our horizontal velocity squared. Now if you plug that in your calculator, you can see that it's 6.26 meters per second, which is 23.7 degrees above the horizontal.
Wait, I don't understand. Does that mean that's gonna land with the same speed below the horizontal as well?
Huh.
Wrong.
As stated before, we know our final velocity in the x direction is 5.73 meters per second. So to find the velocity in the y direction, we know it's not going to be equal because of acceleration due to gravity. So by plugging it into one of our kinematic equations, we can see that our final velocity in the y direction is 3.86 meters per second positive, meaning it's downwards. So if we draw our vector diagram again for the trajectory, we can see that by using trigonometry, we can solve for the angle at which it enters the cup, which is 34 degrees. And using Pythagorean's theorem, we can find the velocity that it enters the cup in, which is 6.91 meters per second, again 34 degrees below the horizontal.
Okay, this makes sense. I think I finally get it. Wait, how'd you get over there?
We can't trust you with this information.
You're just gonna have to forget it.
Wait, what are you doing? Wait, is that Men in Black thing?
No.
Oh man, I just had the craziest dream. Oh my god, look at the time. I didn't do my physics project. What's my idea? Wait, a ping pong ball. Mug also.
Run it, by the service, please no sparklers on them, man.